Welcome to the sixth part of VCAA Specialist Math 2022 exam papers. In this video, we will present exam paper 2, section A, questions 11 to 15. Over 65% of students did well in questions from 11 to 13. However, about 3/4 of students did not answer questions 14 and 15 successfully.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Specialist Math exam paper series. This is section A of 2022 exam 2 paper. There are total 20 multiple choice questions in section A and 6 extended response questions in section B. In this video, we will present questions 10 to 15 in section A. There are 3 vectors in question 11. Vector A equals 2i minus 3j plus pk. Vector B equals I plus 2j minus qk. And the vector C equals negative 3i plus 2j plus 5k, where p and q are real numbers. The question here is to find the relation between p and q if vectors a, b, and c are linearly dependent. Since vectors a, b, and c are linearly dependent, there must be real constant alpha and beta exists such that vector A equals alpha times vector B plus beta times vector C, which is written to alpha times 2i minus 3j plus pk, or in parentheses, plus beta times negative 3i plus 2j plus 5k, or in parentheses. Hence, we have 3 simultaneous equations established to find values of alpha and beta so that the relation between p and q can be found. Here we have alpha minus 3 beta equals 2, 2 alpha plus 2 beta equals negative 3, and negative alpha times q plus 5 beta equals p. From the first 2 equations, alpha and beta can be found. Here, alpha equals negative 5 over 8, beta equals negative 7 over 8. Substituting the values of alpha and beta into the third equation, after simplifying it, we have 8p equals 5q minus 35. Therefore, the answer for question 11 is 8. In question 12, considering the vectors u of x and v of x, vector u of x equals negative cosecant xi plus square root 3j, and vector v of x equals cosine xi plus j. The question is to find the possible values of x if u of x is perpendicular to v of x. Since vector u of x is perpendicular to vector v of x, vector u of x dot product vector v of x equals 0. Hence, negative cosecant xi plus square root 3j dot product cosine xi plus j equals negative cosecant x times cosine x plus square root 3 equals 0, which is simplified to cotangent x equals square root 3. Based on cotangent x equals square root 3, the general expression for x is n pi plus pi over 6, where n is an integer. Taking n equals 0 and 1, x equals pi over 6 and 7 pi over 6, respectively. Therefore, the answer for question 12 is A. In question 13, the acceleration of a body moving in a plane is given by the second derivative of position vector, which equals sine ti plus 2 cosine tj, where t is greater than or equal to 0. The question is to find the velocity of the body at time t given that the initial value of the derivative position vector equals 2i plus j. Since the velocity equals the integral of the second derivative of position vector with respect to t, which is written to the integral of sine ti plus 2 cosine tj with respect to t, which equals negative cosine t plus c1, or in parentheses I, plus 2 sine t plus c2, or in parentheses j. Because the initial value of velocity equals 2i plus j, it follows that negative cosine t plus c1, or in parentheses I, plus 2 sine t plus c2, or in parentheses j, equals 2i plus j, which gives c1 equals 3 and c2 equals 1. Hence, the velocity at time t equals 3 minus cosine t, or in parentheses I, plus 2 sine t plus 1, or in parentheses j. Therefore, the answer for question 13 is B. In question 14, a particle moving in a straight line with constant acceleration has a velocity of 7 meters per second at point A and 17 meters per second at point B. The question is to find the velocity of the particle at the midpoint of AB. We start this question by assuming the constant acceleration is a meters per second squared, and v is the velocity at the midpoint in meters per second. According to the motion formula, that the square of final velocity minus the square of initial velocity equals 2 times the product of constant acceleration and its corresponding displacement. Here, v squared minus 7 squared equals 17 squared minus v squared, which equals 2a times dab over 2, which equals a times dab. Accordingly, v squared equals 7 squared plus 17 squared all over 2, which equals 169, which gives v equals 13 meters per second. Therefore, the answer for question 14 is D. In question 15, an object of mass m kilograms on a smooth inclined plane is acted on by 3 forces, N, T, and W, as shown in the diagram. The force T acts at an angle up from the slope of the plane. The object experiences an acceleration A. The question is to find which one of the given statements is necessarily true. According to the given criteria, the inclined plane is a smooth plane, and the object experiences acceleration. However, we don't know whether the acceleration is upward or downward the plane. If the acceleration is upward the plane, then the modulus of force T times cosine alpha minus the modulus of force W times cosine theta equals m times the modulus of acceleration A. If the acceleration is downward the plane, then the modulus of force W times sine theta minus the modulus of force T times sine alpha equals m times the modulus of acceleration A. However, according to Newton's second law, sigma F equals ma, which gives n plus W plus T equals ma. Hence, the answer for question 15 is E.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.